Hello, myself Mukesh Sirvi. My roll number is 21 ME61R14. Today I am doing numerical modeling assignment on Ansys Workbench. This is the friction stir welding problem statement. We are considering butt welding of 6 mm thick plates, and with we have tool of shoulder diameter 24 mm, and the pin diameter is 6 mm with pin height of 5 mm, and the tool rotational speed is 710 rpm, and the welding speed is 80 mm per minute. Okay, this is the material properties like specific heat and the thermal conductivity. We are considering a non-Newtonian fluid model, and the simulation domain is circular domain diameter is 240 mm, and the rectangular region width is 144 mm. We are st- Now we are starting with Ansys Workbench. This is the Ansys Workbench. First we have save this project to the assignment. Okay, press W, save. Now saving this, and we opening Fluid Flow Fluent, and we are starting with geometry, then mesh, then the setup. On right click, we are opening design modeler geometry. It's opening. Yeah, this is the design modeler where we have to do geometry work. Okay, first we have to select the units, the millimeter. Okay, then select xy plane and modeling setting, and we have grid to show in 2D snaps around by default. Okay, like I'll do one. Okay, now I will create xy plane, select xy plane and select sketch, and look at. Now I have to create one circle. I'll draw a circle and circle. Okay, now I will select the dimension, and the diameter of the circle be 240 mm. Okay, now I will select zoom to fit. This is the circle, and now I'll draw lines, horizontal lines. This is the horizontal line, another horizontal line. Now I'll modify and the select trim and trim rest of part. Okay, okay. And now I will do the dimension of the horizontal length. It is around 144. Okay, and the next dimension, horizontal dimension, that is also 144. Okay, now the geometry part is created. This is our geometry portion. Okay, now I'll do generate and extrude. Okay, now I'll do extrude from geometry applied, add material, direction vector should be reversed. Okay, and the thickness is the 6 mm. Okay, to generate, that portion is created. Okay, this geometry is created. Now our geometry is created. Okay, now our geometry is created. We have to now create the tool. We are now select a new sketch, select XY plane, look at, and sketch 2. We are drawing a circle, and the diameter of the circle is the dimension dia. Dia is the 6 mm. Okay, 6 mm. I have created a dia and constraint concentric. Okay, this circle. Okay, okay. Now I will do the modeling part. First I will do generate and select extrude. Geometry is selected, and now this time not I will select add material. We have to cut the material. Okay, and the direction should be reverse, and the thickness should be 5 mm. Okay, and we will select generate. Okay, now we have cut the material like of 6 mm dia and extruded to the 5 mm thickness. Okay, now we are creating the shoulder dia. So I plane, look at, creating a sketch, and okay, we are creating a sketch. Okay, sketching of circle. For dimension, we are selecting diameter, and the diameter to be 24. Okay, now we'll do constraint concentric, this circle and this circle should be concentric to this. Okay, now generate. Okay, now we'll do extrude. I'm selecting this sketch 3. Now this time I am imprinting the faces. Okay, generate. This will imprint the faces in 2 parts. Okay, now after that I'll do the name selection. Okay, for the name selection. Okay, name selection, and I'll naming first to the velocity inlet. Okay, inlet, and to select the face, I'm selecting this face as a velocity inlet. Okay, Okay, now I will do generate. Okay, now I will again do name selection. Again my name selection is pressure outlet. Okay, pressure outlet. Now I will selecting the face. Hmm, that is my pressure outlet. Okay, apply, selected, apply. Okay, okay. Now I'll do the tools name selection. That should be FSW, FSW tool. Okay, I'm selecting the faces. Okay, second and the third. These three are FSW tool surface. Okay, apply. Now I will do generate and I'll do name selection. Now I'll be selecting the top surface. Okay, and the name is top surface. Okay, okay, generate tools name surface. Now I will be going for the bottom surface. Bottom surface. This is the bottom surface. Apply, generate, and don't need to do name selection for the side surface. These are automatically selected. Now we are done with the our geometry part. Okay, okay, we are done with the geometry. Then we have start with the mesh module. Okay, now we right click on mesh, edit, and it's opening. It's taking a little bit time. Okay, it's opened. Yeah, it's open. For meshing, we have to click on mesh, sizing. First, we have to select name selection, and we are doing at name selection at FSW tool. Okay, and we are selecting the element size given in the problem statement, like 0.5 mm. After that, we will do for the 0.3 mm. Okay, so we are selecting element sizes 0.5 mm. Okay, I will taking the growth rate as a default. Okay, now again I will do the sizing, and this sizing for the geometry selection. I will select the geometry. This is the edge. Okay, and I will for this I will selecting the element size as a 1 mm. Okay, and the growth rate is default. Okay, now I'll do the update. Okay, now the our mesh is done. Okay, okay, we are done with the mesh part. Now we are doing the setup part. Okay, we are opening setup part. Opening. Okay, We start setup part. It's opening. Close it. Okay. We are doing pressure based velocity formulations, absolute and the steady state. First we do general, like general is done. After that we do for the model, and for energy we consider energy equation. Okay. For viscosity we are considering laminar, and option should be viscosity we are considering. Okay. We are done with the models. Okay, now we are creating material. That should be fluid. Creating our material name is AA6061. Okay, the type is fluid. We are taking density as a constant. Density will be 2700, and the specific heat should be polynomial, and we are taking coefficient should be 4 because it's given in the problem statement, like 1 2 3 4. Now we have to put these values at there, and for the first coefficient I will be doing 929 specific heat, and for the second coefficient that will be minus 6.27 E minus 1. Okay, now we are considering third coefficient 1.48 E minus 3. For the fourth coefficient we are considering minus 4.33 E minus 8. Okay, we will do the temperature. Maximum temperature should be equal to 10,000. Okay, we are done with the okay. Create mixture and override air. Should override air. Okay, now we will do the same for the thermal conductivity. It should be polynomial, and the coefficient is same as 4 as the given in the problem statement. For the thermal conductivity the coefficient will be 4. Okay, and same we are putting the constant values 25.2. Okay, now we have 3.98 E minus 1. Okay, now we have 7.36 E minus 6. Okay, last is minus 2.5 E minus 7. Okay, same we will do. Maximum temperature is 1000. Okay, and for viscosity we are considering non-neutral law, Newtonian power law. Okay, and the method will be shear rate and temperature dependent. Okay, we are considering consistency index as 6.88173 E7. Okay, now the power law index is 0.0421. Okay, now the minimum viscosity is 1000 and the maximum viscosity is 1E6. Okay, now the reference temperature is 298 and the activation energy is 1380. Okay, or we will do the change and create. Okay, close. Okay, we have created the material AA6061. Now we are doing boundary conditions for inlet, velocity inlet. Okay, for velocity specification method, we are considering as a magnitude and direction. Reference frame is absolute, and the magnitude is we are considering 0.00133. Okay, the direction should be thermal. We are doing default 300 Kelvin. Okay, apply, close. For outlet, pressure outlet, we are considering backflow as absolute, gauge pressure is 0, and the pressure profile multiplier as a 1, and the direction we are considering as a direction vector. Okay, and the component is 100. Thermal we are considering default 300. Apply, close. Okay, now we are considering the wall boundary conditions. First we are talking about the FSW toolbar. Okay, we are considering it as a moving wall, and the motion is absolute and the rotational. Okay, now the speed is we are considering as 74.351 in radian per second. Okay, axis rotation is axis origin is 000, and the x direction is z direction. Okay, for thermal we are considering as we are not considering any heat flux. Heat flux as is 0. Okay, apply, close. Now we are considering bottom surface, and it is also a moving absolute translation, and the velocity is 0.00133 meter per second, and the direction is 100. Okay, and we are considering thermal properties, convection, and very high like 10,000. Okay, apply. Now we are considering close. Now we are considering top surface, same moving absolute translation, and the velocity is 0.00133 meter per second, direction is same, and now we are considering convection coefficient as 30. It's very small. Okay, apply, close. Now we are considering rest of wall, the side, both side walls, these are also moving absolute translation 0.00133. Okay, considering convection as 30, very small. Okay, and the rotational absolute. Okay, apply. We are done with the boundary conditions. Now we are going through the solution part. For methods, we are considering the default values. Okay, for controls we are also going with the defaults, and we are creating some bunch of report definitions for creating new, and the force report, drag force. Okay, first I'm considering the weld force, weld force, and for the FSW tool. Okay, and okay, now I will also creating another force report, that is for lateral force. Okay, lateral force, and it is the on FSW tool, and the force vector is 0 0 1 0. Okay, now also creating another force report, which is thrust force that is on FSW tool, and the direction is 0 1 0. Print to console to parameter. Okay, now I am interested in moment report. We are creating also a moment report, name as torque on FSW tool. The moment center is 0 0 0 and the axis is 0 0 1, basically a z axis. Okay, okay, now we are done with the report definitions. Now we will do initialization. We are doing hybrid initialize. Now we are doing with the run calculation. We are doing 2000 iterations. Okay, now it's doing calculation. Okay, it will take time around 15 to 20 minutes. Okay, okay, now our calculation is completed. Okay, now we go to the result section, and if we want to see the contours. Okay, so contour 1, we are going to see the contour of temperature. First we can create a new surface. Select plane. We can image weld trans section. Okay, third is point to normal. Okay, and the point is selecting 0 0 0 and normal is 1 0 0. Okay, create, close. Now if I want to compute and display, we are getting this is the temperature contour, and we are getting peak temperature as 590 Kelvin. Okay, close. Now we see the torque and compute. We are getting a torque of minus 37.74 Newton meter. Okay, and thrust force, we are getting a thrust force of minus 4.67. Okay, and for the lateral force, we are getting a lateral force of 16.446 Newton, and for the weld force, we are getting weld force of 12.21 Newton. Okay. And this is the temperature contour. If we are going to see the new contour, and that is in molecular viscosity contour at weld transaction, compute and display. That is the molecular viscosity contour, and these are the scale residuals. And our solution got convert at 356 iterations. Okay, that's all analysis for 0.5 mesh size. Now we will do the calculation for or simulation for 0.3 mesh size. Okay, now we are do simulation for 0.3 mesh size. We have done with 0.5 mesh size. Okay, we are doing, then our geometry part is already done. We are go with the mesh part, edit, and it's opened. Okay, for face sizing, we will do the element sizes 0.0003. That means that is 3 We are taking growth rate as default point 1.2 Okay, and the edge sizing is same. Okay, now we'll do update. Okay, now our message transaction is successful. Now we will go to the setup part, edit. Okay, general properties are same. Now for model, energy equation is on. Okay, and viscous laminar, we are considering model as a laminar, option as viscosity, and rest part is same. Okay, we have done with the mesh. Now our material is A6061, and now we are doing initialization. We are considering as a hybrid initialization method. Now initialization, okay, these are saying that these data are not saved. Okay, okay, initialization. For now we will do again run calculations, and it is for 2000 iteration. Okay, calculate. Okay, now it will do the calculation. Okay, Okay, we are done with the calculation completion for the element size 0.3 mm. Okay, and our solution is get converged at 484 iteration. Okay, so we are maintaining a Excel file for case 2. We are getting element size 0.3 mm, and we have done with the growth rate of point, and the number of iteration is 484. Okay, for this one, if we are calculating the power, torque multiplied by angular velocity, we are getting the power of minus 2.8 kilowatt. Okay, and the peak temperature is 590. And for this, if we require the number of cells, okay, we are getting 184334 cells. Okay, put in. Okay, and for the weld force and various kind of forces, we go to the report definition for the weld force and FSW tool compute. Okay, this is around 15.8379. Okay, not responding. Okay, we are getting weld force of 15.833. Okay, just we are putting in. Yeah. Okay, now for the lateral force compute, this is the lateral force, and for the thrust force we are computing thrust force of 2.87. For the torque we are computing a torque of minus 37.88. Okay, so we are just maintaining a booklet. Okay, and for the thrust force, that is the thrust force and weld force of 5.61, and the angular velocity is same as before. Okay, now for the power calculation, we are getting power, and for peak temperature we are creating a contour tour, and temperature, static temperature, and weld transaction. Okay, compute and display. Now we are getting a peak temperature 591 Kelvin. Okay, that is 591 Kelvin, and similarly the scale residuals are like this. And for contour, we are creating a contour of properties, molecular viscosity at the weld transaction, compute and display. We are getting a contour like this. That's all in this simulation. We have done with 0.5 mm mesh size and 0.3 mm mesh size. Thank you.